Hello everyone, welcome back to my YouTube channel. In this video, I will explain how to solve a questions from EJU's Past Paper Year 2018, second session, Course 2 Mathematics. On my previous video, I already explained how to solve the first two questions from the section 1, and now I will explain how to solve the first question from the section 2. Before we start, please feel free to subscribe my YouTube channel, and if you like this video, don't hesitate to like and share this video. Okay, let's start. The sequence AN is defined by A1 is equals to 2 over 9 and AN is equals to n plus 1 times 2n minus 3 over 3n times 2n plus 1 times an minus 1, where n is equals to 2, 3, 4, and so on. The objective of this question is we are to find the general term an, so we want to find the general term an, and the infinite sum from n equals to 1 until infinity of an. For A until E, in the following sentences, choose the correct answer from among 0 until 9 below. So this is our choices. First of all, when we set Bn is equals to n plus 1 over 3 to the power of n times an, and express Bn over Bn minus 1 in terms of n, we have blah blah blah. So first of all, I want to express Bn over Bn minus 1 in terms of n. If I have Bn equals to n plus 1 over 3n times an, so Bn minus 1 can be found by substitute every n with n minus 1. So first of all, I want to know what is Bn minus 1. So Bn minus 1 is equals to, substitute every n with n minus 1. I will get n minus 1 plus 1 over 3 to the power of n minus 1 an minus 1. If we simplify this expression, minus 1 and plus 1 can be cancelled out. I will get n over 3 to the power of n minus 1 an minus 1. After we got the expression of Bn minus 1, I will divide it by Bn. So Bn over Bn minus 1 is equals to, Bn is this, n plus 1 over 3 to the power of n an over Bn minus 1. We already get Bn minus 1, yeah? This is Bn minus 1. Bn minus 1 is equals to n over 3 to the power of n minus 1 an minus 1. If we move this denominator into multiplication, I will get n plus 1 over 3 to the power of n an times 3 to the power of n minus 1 an minus 1 over n. If you can see the exponential expression here, 3 to the power of n minus 1 is equals to 3 to the power of n over 3. So this 3 to the power of n minus 1, I will change it into 3 to the power of n over 3. So I will change this into 3 to the power of n over 3. From this expression, we can cancel out the 3 to the power of n. And I will get n plus 1 over 3 to the power of n, 3n I mean, times an minus 1 over an. Just rearrange this expression. From this, I already know the answer for letter A and B. A is n plus 1, B is 3n. So A is n plus 1, which is number 2. And then B is 3n. 3n is number 8. And from this expression, it can be changed into a new expression. N plus 1 over 3n times an minus 1 over an is equals to blah blah blah. The idea is I have to change an minus 1 over an here, so that we will obtain the final answers there. What is an minus 1 over an? You can see from our equations above. From these equations, an minus 1 over an minus 1 over an, substitute the an to the right hand side, is equals to, this expression is moved to the left hand side, so it becomes 1 over all of this. And I will get 3n, 2n plus 1 over n plus 1, 2n minus 3. So from this equation, if I rearrange that into an minus 1 over an, I will get this expression. Then substitute it into our expressions. By substitute this into that, I will get, let's move over here, I will get bn over bn minus 1 is equals to n plus 1 over 3n times an minus 1 over an is this, times 3n 2n plus 1 over n plus 1 times 2n minus 3. Of course, I can cancel out 3n and n plus 1. So my final answer is bn over bn minus 1 is equals to 2n plus 1 over 2n plus 3. This is the answer for letter C and D. So letter C is 2n plus 1, which is number 4. And then letter D is 2n plus 3. 2n plus 3 is number 6. Oh, I mean 2n minus 3. This is 2n minus 3, not 2n plus 3. So this is minus. So letter C is number 4 and letter D is 2n minus 3, which is number 5. And then from these equations, we have an equals to blah blah blah. So now we want to find what is an. What is an? They already tells us that an can be found from these expressions, which is an is n plus 1 over 3 to the power of n times bn. So you move the bn down there and you move an up there. So from these equations, I get an is equals to n plus 1 over 3 to the power of n bn. Now I have to know what is bn in terms of in terms of one of these polynomials. Because n plus 1 is already the same, like that, and then 3 to the power of n is also the same. So I need to change Bn. And my prediction is Bn must be equals to blah 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 times 2n plus 1. So now we have to think about what is Bn. From this equation, Bn is equals to 2n plus 1 over 2n minus 3 times Bn minus 1. I will start to think about the pattern of B of n, or Bn. If I want to know the pattern of Bn, I have to know what is B1, and then what is B2, and then what is B3, and so on. After I got B1, B2, B3, and so on, I have to predict the pattern of Bn. Let's start from B1 first. If I want to know B1, we can use this expression. Just substitute n with 1. So B1 is equals to 1 plus 1, which is 2, over 3 to the power of 1 over 3 times A1. What is A1? The questions already give us A1. A1 is equals to 2 over 9. Cancel out 2, 3 and 9. I got 1 over 1 over 3, which is 3. So B1 is equals to 3. This is our B1. How about B2? To find B2, we can use this expression. I will use this expression to find B2. Just substitute n with 2. Substitute n with 2. 2 times 2 is 4. 4 plus 1 is 5. Over 2 times 2 is 4. 4 minus 3 is 1. Times B2 minus 1, which is B1. If you substitute n with 2, 2 minus 1 is equals to 1. Then these expressions becomes B1, which is 3. So my B2 is 5 over 1 times 3. I can write it as 5 times 3. And then B3. What is B3? Once again, I will substitute n with 3. 2 times 3 is 6. 6 plus 1 is 7. Over 2 times 3 is 6. 6 minus 3 is 3. Times n is 2. 2 minus 1. N is 3, I mean. 3 minus 1 is 2. So this expressions becomes B2. B2 is 5 times 3. Cancel out the 3. You got 7 times 5. This is B3. I think from these 3 terms, you already know the pattern of Bn. B1 is 3. B2 is 5 times 3. B3 is 7 times 5. If I guess B4, I think B4 must be equals to 9 times 7 and so on. You can check it by yourself, yeah? Is it correct? B4 is 9 times 7. I'm pretty sure it is correct. B1 is 3. B2 is 5 times 3. B3 is 7 times 5. So the pattern of Bn is the multiplication or the product of 2 odd number. I can rearrange it as 1 times 3, 3 times 5, 5 times 7, and so on. To express an odd number, we can use 2n minus 1. You can see if I substitute n with 1, I got 1. If I substitute n with 2, I got 3. If I substitute n with 3, I got 5. This is the general term or the general formula for an odd number, 2n minus 1. So Bn is 2n minus 1. This is the first odd number. And then the next odd number is 2n plus 1. 2n plus 1 will represent 3, 5, 7 when n equals to 1, 2, 3, and so on. If I check it, if I substitute n with 1, 2 times 1 plus 1 is 3. If I substitute n with 2, 2 times 2 plus 1 is 5. And then if I substitute n with 3, 2 times 3 is 6, 6 plus 1 is 7. So 2n minus 1 times 2n plus 1, this is Bn. After I got Bn, I already know what is An. This is our questions, yeah? We want to find An. So An equals to n plus 1 over 3 to the power of n times Bn. Bn is 2n minus 1, 2n plus 1. So letter E here is 2n minus 1. 2n minus 1 is number 3. So the answer for letter E is number 3. Okay, next, let Cn equals to 1 over 3 to the power of n times 2n plus 1. When we set An equals to A times Cn plus 1, Cn minus 1, plus B times Cn, we see that A equals to blah 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 and B equals to blah blah blah. So I have to know what is A and B here. First of all, I will set An. Our An is this expression. An is equals to capital A Cn minus 1 plus B Cn. An equals to capital A Cn minus 1 plus B times Cn. An is this expression, n plus 1 over 3 to the power of n to n minus 1 to n plus 1. This is our An is equals to A times Cn minus 1. They already give us the Cn. So to find Cn minus 1, just substitute n with n minus 1. So it will becomes 1 over 3n minus 1 times, if you substitute n by n minus 1, you will get 2n minus 1 plus 1, which is 2n plus 1. This is A times Cn minus 1, and then we have to add it with B times Cn. Plus B times Cn. They already give us the Cn. Cn is 1 over 3 to the power of n over 2n. Oops, I think I've made a mistake. Yeah. Sorry, wait a minute. Yeah. 2 times n minus 1 plus 1 is 2n minus 1, yeah? Not 2n plus 1. So this is 2n minus 1. My bad. 2n minus 1. And then for b times cn, we will get b times 1 over 3 to the power of n 2n plus 1. This is b times cn. If we simplify this expression, you can see there are 3n minus 1 here. Like I say before, 3n minus 1 is equals to 3 power n over 3. So I will change this into 3 to the power of n over 3. And then the 3 here can be moved to the numerator. So I will erase this, and this expression becomes 3. And then if I multiply a by 3, I will get 3 times a, which is 3a. 3a. So after we simplify the expression, I will get this. And then b times 1, I will get b. So it becomes b. We got this expression at the end. And I have to know, or I have to find the value of a and b. What is the value of a and b? If you see this kind of equation, you can find the value of a by making the right-hand side into single fraction. So I will multiply 2n plus 1 on the first expression here. 3a, 2n plus 1. If I multiply it on the top, I also have to multiply it on the bottom. So it will not change our expressions. And then multiply 2n minus 1 on our second fraction. b times 2n minus 1 over 3 power n 2n minus 1 2n plus 1. So our fraction already have the same denominator. The denominator is already the same. Once the denominator is already the same, we can write it as a single fraction. Just distribute 3a into the bracket. I will get 6an plus 3a plus distribute b into the bracket plus 2bn minus b. It should be equals to this. It should be equal to this. As you can see, since the denominator is already the same, we can compare the numerator. So what I do is I will compare the numerator because the denominator is already the same. So n plus 1 is equals to, we have to group the n. If you factorize the n, you will get n 6a plus 2b. And then the constant term is 3a minus b. And then just see or compare the coefficient of n from the left-hand side and right-hand side. From the left-hand side, the coefficient of n is 1. From the right-hand side, the coefficient of n is 6a plus 2b. And then also compare the constant term. From the left-hand side, the constant term is 1. From the right-hand side, the constant term constant term is a term which is independent of n. So the constant term is 3a minus b. Finally, we get simultaneous equation. We can solve it by using substitution or elimination. I think I will eliminate it. Times 1 times 2. We got 1 equals to 6a plus 2b. And then from the second equation, I get 2 equals to 6a minus 2b. If I add these two expressions, I will get 1 plus 2 equals to 3 equals to 12a. Then a equals to 1 over 4. After we got a, just substitute it back into one of those two equations to find b. 3 times a minus b, 1 equals to 3 over 4 minus b, then b is equals to negative 1 over 4. Finally, I got the value of a and the value of b. A is 1 over 4. So f is 1, g is 4. And then b is negative 1 over 4. So hi is negative 1 and j is 4. Okay, next, using this result, we already know the value of a and b, right? By using this, find Sn. Sn is the sum of the first n term. Our an is 1 over 4. A is 1 over 4. Cn minus 1 plus b is negative 1 over 4 Cn. This is our an. What I want to find is Sn is equals to sum of k minus 1 until n from ak. If I want to know the expression of ak, I just substitute n by using k. So Sn is equals to sum from k equals to 1 until n from 1 over 4 ck minus 1 minus 1 over 4 ck. How to solve or how to find these equations? How to simplify this equation? To simplify this equation, you can put the value of k into there. And once again, we have to see or we have to know the pattern of our expressions. If I substitute k into there, I got 1 over 4 c0 minus 1 over 4 c1. Since this is the sum, that means we will add it with the second term. Substitute k equals to 2 into our expressions. K equals to 2. 2 minus 1 is 1. C2 and then plus the next term k equals to 3. 1 over 4 C2 minus 1 over 4 C3 and so on. As you can see, this expression will be cancelled out. Negative 1 over 4 C1 plus 1 over 4 C1. It will be cancelled out. This expression is also cancelled out. If you do the same thing into the last term is when k equals to n, I will get the last term is 1 over 4 ck minus 1 minus 1 over 4 ck. It should be cancelled out until this one. It should be cancelled out and so on until this one. So the final result is only 1 over 4 CO minus 1 over 4 C, oh sorry, K is N, yeah? So 1 over 4 CO minus 1 over 4 C, and this is N. So this summation will give us Sn equals to 1 over 4 CO minus 1 over 4 Cn. 1 over 4 CO minus 1 over 4 Cn. And then, since they want us to express this like that, so I need to simplify. It. CO is, substitute N with 0. 1 over 3 to the power of 0 times 1. So CO is equals to 1. CO is 1. So Sn is equals to 1 over 4 times 1 minus 1 over 4 times Cn. If we factorize the 1 over 4, I got 1 over 4, open bracket 1 minus Cn. I think this is our expression for Sn. So K is 1, L is 4, M is 1. And then finally, hence we obtain the sum to infinity from 1 until infinite, yeah? This is sum to infinity of An is equals to the limit n approaches infinity of Sn. So we have to find the limit n approaching infinity of Sn. N approaches infinity Sn. What is Sn? We already find the Sn. Sn is 1 over 4, open bracket 1 minus Cn. So it should be equals to limit n approaches infinity from 1 over 4. I will distribute 1 over 4, the 1 over 4 into the bracket. 1 over 4 minus 1 over 4 Cn. Limit n approaches infinite from 1 over 4 minus 1 over 4. What is Cn? They already give us the Cn. Cn is 1 over 3 to the power of n times 2n plus 1. Okay. By substitute the n with infinity, we will get the result of that limit. So I will substitute n with infinity. I will get 1 over 4 minus 1 over 4 times 1 over 3 to the power of infinity, 2 times infinity plus 1. Of course, this expression will give us 0 because 1 divided by a very big number. 1 divided by a very big number will approaches 0. And then 1 over 4 times 0, of course it is 0. Then my final answer is 1 over 4. This is the final answer of these questions. Okay, thank you guys for watching this video, and I hope you guys can understand my explanations well. Okay, that's enough for today. See you guys on my next video. Thank you and bye-bye.